Okay, this video is going to be dealing with reviewing for the test, our Unit 1 test, which will be tomorrow, Friday. So here's some problems. What I did was I went through the problems from our worksheets that we had, and these are the answers to all the problems. So I would like you to kind of look through them, make sure that, let me move this over here, make sure that your answers all match what's going on in here. Make sure your answers are exactly the same, because some of the questions you might have a different form of it, and this is the form that we're going to be seeing. So what I want you to do is to go through, do the problems first, and then check the answers. And if you don't have the same answer, try to figure out why. What I'm going to do now is I went through and selected a handful of problems. I don't want to do all 50 of them because it's going to take forever, and I know I don't want to make this a super long video either. So I'm just going to explain a couple of problems that will definitely be on the test tomorrow. First of all, we're going to look at this one here. This is solving a problem with an absolute value in it. Now, the idea with an absolute value is, in order to solve for this, I have to get the x by itself. So my first step, of course, is going to be, well, not the first step, but at some point I have to isolate this. I have to isolate this part of it. So that's absolute value is all by itself on one side of the equation. So what I would do now is I'm going to say add 6 to both sides, because that gets the absolute value by itself. Now when I do that, the 6's cancel, and I have absolute value of, oops, let me write this better, absolute value of 10 minus 7x equals now 26 plus 5 is, I have 25 plus 6 is 31. And now I've got to the point where the absolute value is all by itself on one side of the equation, and that's good. And then what I need to do is get rid of the absolute value signs. And what that means is, just so the meaning of it is, this entire thing here could either be equal to 31, so I say 10 minus 7x equals 31, or this entire thing I circled could be equal to negative 31. 10 minus 7x equals negative 31. I know a lot of people just say I write two equations and don't know why. This is why, because the circled part could be equal to 31. That would be square root of 31 is 31. Or it could be equal to negative 31, because the square root of negative 31 is also 31. So now I go through steps like an 8th grader to solve this. So what I'm going to do is subtract 10 from both sides. And I have negative 7x equals 31 minus 10 is 21. And here I subtract 10. Well, let's finish solving this. Then I solve this one here. Divide by negative 7. Divide by negative 7. X equals negative 3. So negative 3 would be one solution. And then I'm do the other one. Negative subtract 10 from both sides. Negative 7x equals negative 41. And now it's a little bit more tricky, but that's okay. Trickier, I guess is a better word. This is a little trickier, so this cancel, and I got x equals 41 over 7. I want to see if this, now both of these should work, but we've got to check to make sure they work. So when I plug negative 3 in here, I got the absolute value of 10 minus 7 times negative 3, absolute value, minus 6 equals 25. So the absolute value of 10 minus a negative, because this is going to be minus negative 21, so 10 plus 21, absolute value, minus 6 equals 25. This becomes absolute value of 31 minus 6 equals 25. So this becomes 31 minus 6 equals 25, which is true. So that means negative 3 is a solution. And then I want to try the other one here. So I'm going to try 41 over 7. It looks a little more difficult, but it'll work out nicely in a second. So what I'm going to do is I'm going to say 10, absolute value of 10 minus 7 times 41 over 7. And then I finish the problem, minus 6 equals 25. So this becomes absolute value of 10 minus, the 7's are going to cancel, 10 minus 41 minus 6 equals 25. So the absolute value of negative 31 equal minus 6, not equals, minus 6. 31 minus 6 equals 25, and that's the absolute value. That's 31 minus 6 equals 25, which works as well. So both of these are solutions, and that's fine. Let me pause this right now. Okay, the next problem we're going to go over deals with inequalities. Now, and this is a similar situation. I have absolute value of negative 2 plus x minus 9 is greater than or equal to negative 4. And I want to isolate the absolute value just like before. So what I'm going to do is add 9 to both sides. So that becomes absolute value of negative 2 plus x is greater than or equal to 5. And now I'm going to write two equations for this one. Well, actually, technically inequalities, but it's the same idea. Negative 2 plus x is greater than or equal to 5. Or negative 2 plus x is less than or equal to negative 5. What we do is once we have the absolute value isolated, we write two equations, one just as it is without the absolute values, and one where we switch the direction of the arrow and switch the sign of the right number. So now I'm going to add 7 to both sides, add 2 to both sides, and I got x is greater than or equal to 7. And here I add 2 to both sides. X is greater than, not greater than, less than or equal to. X is less than or equal to negative 3. So that's basically it. Now when I put those numbers in, since these are lines underneath them, that means it's a closed circle. So greater than 7 looks like this. And less than negative 3 looks like this. So the idea is any number that's bigger than 7 will be true. Any number that's bigger than negative 3 will make this true. Any number in between will not make it true. Will make this a false statement. Okay, let's move on a little bit. This one here, it's actually just a straightforward 8th grade problem. We're going to distribute this, so it gets negative times a negative is positive, 54 times x, minus 54, and then we got plus, distribute this, plus 64x, plus 32, and I combine like terms. 54 plus 64 is, what is that, 118x. Negative 54 plus 32 is, what is that going to be, 22, minus 22. That's all we want to write for that one. So that's it. Kind of a quick problem there. As we move on, now we deal with complex numbers or imaginary numbers. We've done a bit of this already. This is just when we do operations with imaginary numbers, the i's, or complex numbers, like this. We just want to treat the I like it's an x and do the same thing we always did. The only difference is when we get an I squared, we make it negative 1. So first I'm going to do negative 7i times 3, which is negative 21i. Then I'm going to do negative 7i times negative 2i. Negative times negative is positive. So it's plus 14i squared. Now the only that's the first part, it's just treating it like an x. Now we take this I squared and change it to negative 1. So that's going to be negative 21i. 14 times negative 1 is negative 14, so minus 14. Now this is technically not the way to write a complex number. We would put the real part first, the part without the I, and then minus 21i, and that's how the answer would look, or should look. As we move on, now this is confusing to a lot of people because they see the parentheses and they automatically think we're supposed to multiply and do FOIL, and they start doing this and all that. That's not what we want to do here. This is just a subtraction in the middle. It's just a basically simplifying. Now, when we want to simplify this, my suggestion is write it again, but this time without parentheses. When there's no number in front of that first parentheses, it's just written as it is. But this minus sign changes the signs inside. So minus 5 here, and then negative times a negative is plus 3i. And then I just combine like terms. 4 minus 5 is negative 1. 4i plus 3i plus 7i. And that's it, and we're done with the problem. That's all there is to it. There's no multiplying, no foiling, no I squareds or anything. So be careful. If this middle thing here is not, if there's something inside here, plus or minus, we're just going to add or subtract. We don't have to worry about FOIL. This one here, there is nothing in between, so now we are going to multiply, or we like to think of it as FOIL. 3 times 4, that's 12. 3 times 4i, that's plus 12i. And negative 3 times 4 is minus 12i. And negative 3i times 4i is minus 12i squared. Now what I do, to simplify this, I like to do it in steps. I'm just going to take care of the middle terms here right now, and I'm going to say that's going to be 12 still. Then 12i minus 12i cancel, so they're gone. And then instead of saying minus 12, I'm going to look at this minus 12 as minus 12 times negative 1. But 12 times negative 1, negative 12 times negative 1 is plus 12. So plus 12. So 12 plus 12 is 24, and that's the answer we're looking for that one. All right, good stuff. Now here, when we have an I in the denominator, we don't want that. That's a square root. So to get rid of that I, we're going to multiply top and bottom by I. Actually, not square root, right? Just by I. So I put I on top and bottom. Technically, I'm multiplying the whole thing by 1, so I'm not changing the value. So this top now becomes I, and the bottom becomes 3i squared. Well, I squared is negative 1, so that's going to be I over negative 3, or probably as a multiple choice would be looking like this. Negative I over 3 would be how they actually write the answer. Now, some of you may have said, if you have, some of you might have said 1 over 3i. If you did this, you said, I'm going to put 3i over 3i. It still works. What happens there is you get 3i over negative 9. And the 3's cancel to be 1/3. It works to be the same thing. Either way. This way, you don't need, the 3's okay to have on the bottom, just not the I. Okay, the next problem we're going to work on looks like this. Now, this is a little different because we have a binomial in the denominator. So we have to multiply by the conjugate. So remember, when you see the word conjugate, okay, what that is the same thing as what's written here, but with the middle thing changed. So this would be 9 plus 6i. So 9 plus 6i. We'll do that. So now what I'm going to want to do is distribute, because this is basically parentheses. So 7i times 9 is 63i. 7i times 6i is plus 42i squared. That's the top of the fraction. The bottom, when I do this, I'm multiplying binomials together, which we use as FOIL. So that's going to be 81. And this will be plus 54i. And then minus 54i will be from these two here. And then I'm going to say minus 36i squared. Now, when you multiply conjugates together, these middle terms will always cancel out. And that's a good sign that we did it correctly. So top of the fraction, this becomes 63i. And then this is going to be minus 42. In the bottom now, I have 81. And this is going to be minus 36i squared. I squared is negative 1, so plus 36. So that would be, I'm going to write this a different way. Put the non-imaginary, the real part first, 42, the part without the I, plus 63i. This is the same thing, I just put the order differently. And the bottom is 81 plus 36, which is 117. Now, sometimes the answers are written like this. Technically, it should be written like this. Negative 42 over 117 plus 63 over 117 times I, or maybe 63I. This is the correct way to technically write it. It might be written this way if it's multiple choice. Okay, a couple more problems to go over. Actually, quite a few more. Okay, this one here we have fractions with exponents. We have to work on our exponents a little bit. What I like to do with this is when I have negative exponents, that's always an issue, so I have to deal with that first. So what I do is I take each number that's in the entire fraction and decide whether to leave it where it is or move it from top to bottom, or bottom to top, depending on what we have. Now the 3 has a positive exponent, leave it where it is. The a has a positive exponent, leave it where it is. This 3 has a positive exponent, leave it where it is. This a has a negative exponent, so I move this one from the bottom up to the top. So that's going to become another a to the first. B to the fourth is a positive exponent, stays where it is. This 3 is positive, has a positive exponent, stays where it is. This b has a negative exponent, so this moves to the top as b to the positive third. And now simplifying, first I'm going to take care of all the coefficients or numbers in front. So I have 3 on top, 3 times 3 on the bottom. When everything's multiplied, you can cancel off things into the same if you want. So basically I'm going to have a left on just a 3 on the bottom. Now the top part, I'm looking for my a's now. Okay, we have a's on top. There's only a's on top, and there's 1 here and 1 more, so that's a to the second on top. And the b's, now I have 3 b's on top and 4 on the bottom. There's different ways of doing that. What I like to ask myself is, are there more b's on top or bottom? And there's more on the bottom. So now the next question is, how many more? And there's just 1 more, so it's just b to the first. So that would be the final answer right there. Okay, let's move on to number 39. I'm going to jump forward to get some stuff done now. Here we want to get rid of this square root symbol. So to get rid of the square root symbol, I have to square both sides. But I don't want to square it yet until I isolate the square root symbol, square root. So what I'm going to do is subtract 1 from both sides first. So I have 10 equals the square root of 14x plus 2. And now I have a square root that I have to deal with. How do I get rid of a square root? Well, if I squared it, that's going to get rid of it. The square roots squared cancel each other out, so I have to square this. If I square that one side, I must square the other side. So now I have an equation that says 100 equals the square root of a square. These cancel each other out, and I'm just left with what's under the square root, 14x plus 2. And now to solve this, I'm going to subtract 2 from both sides. And that's 98 equals 14x. Next step is to divide both sides by 14. So x equals whatever 98 divided by 14. So x equals 7. And that would be your final answer there. Now I always want to check with absolute value signs and put them back in. So 11 equals the square root of 14 times 7 plus 2, and then plus 1. So 11 equals the square root of 98 plus 2 plus 1. 11 equals the square root of 100 plus 1. 11 equals 10 plus 1. That's true, so this is a correct solution. Okay, 45. This one's a little tricky because we have to change these exponents, this into fractional exponents. That's what we're asked to do here. So here's the rule that we're going to have. We're going to have, I'm going to put x to the power of a over b. That would be equal to, in radical form, the bottom number always goes in here, and the top number can either be written like this, Or sometimes it could be written like this, bx and the whole thing to the a like this. So both of these are really the same thing. Let me make that a little clearer here. It's hard to see that a. That's an a. So the top number is going to be the exponent here, either inside the radical or outside. It doesn't really matter. They're both the same, turn out to be the same thing. The bottom number is always the index here. Now, if you have a 2 as a thing, like if you had x to the 5 over 2, what would happen then is you'd have this to be this, and there'd be a 2, and then x to the 5th. But sometimes this 2, we don't need to write that, so it's just the square root of x to the 5th would be the answer. So this is the same type of thing. We're going to go this entire thing for r, but the whole thing is, that's what's underneath there. The exponent now is going to be a fraction. The bottom number is the number inside of here, so that's a 3. And the top number is this one, which is a 4. This, I guess, is a little bit more common way to write it. They're both the same, but this is a little more common. So that's what we have for the answer here. This would be my final answer for that problem. For this problem, we're going to go backwards. So basically, we're going to write 4n under the radical symbol, and we've got to figure out where does the 5 go and where does the 3 go. The bottom number always goes here. The top number, typically, we just put it out here like this. Or sometimes it might, well, let's leave it like that. If you did it inside, you have to be careful, because if you just did this, that would mean only n's to the 5th. We'd have to do that with the parentheses. But either way, that's fine. Okay, I'm going to pause. Okay, before I finish, I want to go over one problem that wasn't on the worksheet, but it will be on the test, and we should know it. But let's suppose I had a problem that looked like this. The square root of 2x plus 19 equals x plus 2. Now that's a little different because the x is outside. So what I would do now is, just like we did before, I want to get rid of the square root. I've got to square both sides. But when I square this side, I'm going to square, let's just write this again. So when I square the right side, left side, it looks like this. I got to square the right side, which means I'm going to have to FOIL that. I multiply the binomial. So these cancel, and I got 2x plus 19 equals, now x plus 2 times x plus 2. I'll do that separately. X squared plus 2x plus another 2x plus 4. So that's going to be equals x squared plus 4x plus 4. And now my steps are get rid of this. I want to see if I can solve this by factoring. But to do that, I got to make the left side equal 0. So I'm going to go through some steps. Subtract 2x, subtract 2x. So these cancel, and I got 19 equals x squared minus, or plus 2x plus 4, and now I'm going to subtract 19 from both sides, and I have 0 equals x squared plus 2x minus 15. Now what I want to do is see if I can factor this bottom thing, this right side here, and that would look like this. 0 equals, parentheses, I'm going to try to do that, see if it works, x and x. I'm looking for numbers that multiply to 15 and subtract to 2. That works out to be 5 and 3. Now the bigger number always gets this sign right here, which happens to, in this case, be plus, and this is minus. Now I haven't solved it yet. I haven't solved it till I write x plus 5 equals 0, in which case x equals negative 5. X minus 3 equals 0, x equals 3. And now at this point, I have two answers, but I want to see if they work, because sometimes they do, sometimes they don't. Now, when I check in with 3, let's put 3 in there, and I'm going to check 3 like I did earlier. I put that in, so that's square root of 2 times 3 plus 19 equals 3 plus 2. Get it in green, probably. 3 plus 2 is the right side. So all I did, notice I just changed the x's in the problem to 3's to see if it works. So I have the square root of 6 plus 19 equals 5. So that's the square root of 25 equals 5, and that's true. So 3 is a solution to this problem. But when I check negative 5, I'm going to have square root of 2 times negative 5 plus 19 equals negative 5 plus 2. Again, I did the same thing I did here, only I'm changing the x's to negative 5. So now this would be square root of negative 10 plus 19 equals negative 3. So that's the square root of 9 equals negative 3. 3 equals negative 3. It does not equal. So these are not equal. So 5 is not a solution. Negative 5 is not a solution to the problem. There's a word for that. It's called the extraneous. And I'll give you a hint. You need to know this name on the test tomorrow, because I asked for the extraneous solution, which in this case would be negative 5. Okay, hopefully that helps. Good luck studying, and I'll talk to you tomorrow.